Right now, you are sitting somewhere. A room, a car, a train. And underneath that simple fact is a question you have never let yourself fully ask. What was there before the beginning of everything? Not before your life, not before Earth, before time itself. Most people assume scientists have an answer tucked away somewhere, a clean diagram with a label that says, here is what came first. They don't. And the real answer is far stranger than silence, or darkness, or empty space waiting for something to happen. Because none of those are actually nothing. Start with the word itself. Nothing. You picture an empty room, a black void, maybe deep space, cold and still. But every one of those images already contains something. A room has walls. A void has darkness, which is still a property. Even deep space has space, which is a real physical structure that can stretch, bend, and ripple. True nothing would have no space to be empty in, no time for that emptiness to last. No laws of physics waiting in the background to eventually switch on. Try to picture that for more than a few seconds. You can't. Your brain was built by evolution to predict what happens next in a world full of things. It has no tool for picturing a world with no things and no next. So when you ask what came before the Big Bang, you are already smuggling in an assumption. The word before assumes time was running, ticking forward, with one moment following another, the way it does for you right now. But what if time itself only started at that moment? What if asking what happened before the Big Bang is a little like asking what is north of the North Pole? You can spin a globe and search forever. There is no answer, because the question contains a hidden error. North is a direction that only makes sense once you are somewhere else on Earth. At the pole itself, north stops meaning anything at all. This was the radical idea proposed by physicists James Hartle and Stephen Hawking in the 1980s. They called it the no-boundary proposal. In their model, time behaves like an ordinary dimension of space near the very beginning, smoothly curving rather than hitting a hard wall. There is no edge for time to suddenly switch on at. The universe is, in their words, self-contained. Nothing precedes it because the concept of preceding doesn't apply yet. Not a closed door, not a wall, just the absence of a question that used to make sense. Does that satisfy you? It shouldn't, not entirely. Because even if time began at the Big Bang, something still has to explain why there was a beginning at all and why it looked the way it did. Here is where the story gets genuinely strange. Physicists can describe the universe in exquisite detail starting an incredibly tiny fraction of a second after the Big Bang. But there's a wall they hit much closer to the start, a span of time so short it barely deserves the word. 10 to the negative 43 seconds. A decimal point, 42 zeros, then a 1. This sliver is called the Planck epoch. During it, the four fundamental forces of nature were likely unified into a single force, and the temperatures and densities were so extreme that general relativity, our best theory of gravity, simply breaks down. The math stops giving sensible answers. To go further back, physicists need a theory of quantum gravity, something that successfully merges Einstein's relativity with quantum mechanics. That theory does not exist yet. So when someone tells you confidently what happened before the Big Bang, they are speaking past the edge of established physics. What follows isn't nonsense. It's some of the most serious mathematics in modern science, it's just not yet proof. One of the oldest ideas in the modern version of this question came from Georges Lemaitre, a Belgian physicist and Catholic priest, who in 1927 proposed that the universe began as what he called a primordial atom, a single concentrated point that expanded outward into everything we see today. Lemaitre's idea eventually became the seed of Big Bang cosmology. For decades after, many physicists, including a young Albert Einstein, actually resisted the idea, preferring to imagine an eternal, unchanging universe. It took the discovery that distant galaxies were rushing away from us, the unmistakable signature of cosmic expansion, to convince most of the scientific community that the universe truly had a beginning. But a beginning of what exactly? This is where the modern theories branch out, each one trying to answer the same haunting question from a different angle. Consider the idea of eternal inflation, developed in different forms by physicists, including Alan Guth and Andrei Linde. In this picture, our Big Bang wasn't a single unique event. It was one bubble of rapidly expanding space, foaming up out of a much larger, eternally inflating field. Other bubbles, other universes with potentially different physical laws, may be forming elsewhere in that same field right now, separated from us by distances that will never be crossed, even at the speed of light. Under this view, asking what came before our Big Bang is like asking what existed before one particular wave formed in an ocean that was already there. The ocean doesn't need a beginning, the wave does. Then there's the cyclic universe, an idea explored by physicists such as Paul Steinhardt and Neil Turok. Instead of a single origin, this model imagines the universe expanding, eventually slowing, collapsing back in on itself, and bouncing into a new expansion again and again, perhaps without end. Each Big Bang in this story isn't a true beginning. It's a turning point, a big bounce, one chapter folding into the next. Turok has taken this even further, proposing a radically different twist. What if the Big Bang created not one universe, but two, a mirror pair joined back to back? Our universe expands forward in time, while a second universe made of antimatter expands backward in time from the same originating point. In this picture, the two universes are reflections of each other across the moment of the bang itself, almost like a single object and its image in a mirror, except the mirror is time. Each of these models, eternal inflation, the cyclic universe, the mirror antiverse, the no-boundary proposal, is mathematically rigorous. Each one is consistent so far with everything we can actually observe. And each one gives a completely different answer to your original question. That should tell you something important. The disagreement isn't because scientists are guessing wildly, it's because the available evidence, mainly the faint afterglow of the Big Bang called the cosmic microwave background, doesn't yet distinguish clearly between them. Several very different pasts can produce the same observable present. There's a fourth idea worth sitting with, one that approaches the question from physics at the smallest possible scale instead of the largest. It's called the quantum vacuum model, and it starts from a strange but well-tested fact. Empty space, even in the universe you live in right now, is never perfectly empty. Quantum mechanics predicts that even a true vacuum seethes with tiny fluctuations, particles flickering into existence and vanishing again, far too briefly to violate any law of physics. This isn't speculation. It's been measured in laboratories in an effect called the Casimir effect, where two metal plates placed extremely close together get pushed slightly together by the pressure of the vacuum itself. Some physicists ask a daring follow-up question. If a vacuum can produce fleeting particles, could a large enough quantum fluctuation produce an entire universe? Under this model, our universe wouldn't need a creator, or a previous universe, or a boundary condition at all. It could be the result of a random fluctuation in something even more fundamental than ordinary space and time, a kind of pre-geometric quantum foam with no clock running inside it yet. The strange part isn't that this idea sounds far-fetched. The strange part is that the mathematics behind it is taken seriously by working cosmologists, even though no one currently has a way to test it. Is that frustrating? It might be. But it's also a kind of honesty rare anywhere else in human life. Most of human history is built on confident answers to unanswerable questions. Ancient cultures filled the silence before creation with gods, with cosmic eggs, with endless turtles stacked on the backs of other turtles. The discomfort of not knowing where everything came from is not new. What's new is a civilization mature enough to say, clearly and repeatedly, "We don't know yet," and to keep searching anyway instead of settling for a comfortable story. There is a reason this particular question refuses to let go of you. Your brain evolved to demand causes. Every effect needs a reason, a previous event, a story that explains the next. That instinct served your ancestors well. It is also exactly the instinct that breaks down at the edge of time itself, where the rules that built your intuition may simply not apply. So here is where this leaves you. Tonight, when you look up and see stars, you are looking at light that began its journey before recorded history. Some of that light left its source before the first cities, before written language, before anyone stood on two legs and wondered about anything at all. And underneath the oldest light we can detect is a boundary we still cannot see past. Not because we haven't looked hard enough, because the very language of before and after may dissolve completely once you get close enough to it. Think about how strange that actually is. You go through your entire day assuming there's always a previous moment to point to. Why did you wake up at that hour? Because you went to sleep at a certain time. Why did you go to sleep then? Because of what happened earlier in the day. Every question has a parent question, stretching backward, link by link, like a chain you could follow forever if you had the time. The beginning of the universe might be the one place where that chain simply has no further link to find. Not because it's hidden from you, but because the chain itself may not extend that far back. Maybe that's uncomfortable. Most people prefer chains with no missing links. But consider what it would mean if scientists had a tidy, complete answer to this question right now. It would mean the universe ran out of mystery at its absolute outer edge, the one place mystery seems like it belongs most. Instead, you live in a universe that keeps a secret about its own birth, guarded not by gods or fate, but by the genuine limits of physics as we currently understand it. You will probably never get a final answer to this question in your lifetime. Neither will the physicists working on it right now, the ones spending entire careers trying to merge gravity with quantum mechanics, hunting for the one theory that might finally tell us whether time had a true beginning or simply curves back on itself like a circle with no start. But maybe the point was never to reach the edge and find a label there explaining everything. Whatever happened next changed everything forever, and you are still living inside the question it left behind.